The increase and decrease in temperature in a chemical reaction. Temperature is an important factor in chemical reactions, as it affects the rate and extent of the reaction. Changes in temperature can lead to changes in the energy of the molecules, which can affect the activation energy required for the reaction to occur. In this essay, I will discuss the effects of temperature on chemical reactions, including the factors that influence the temperature dependence of chemical reactions. Temperature and reaction rate. Increasing the temperature of a chemical reaction usually increases the rate of the reaction. This is because the increased temperature leads to an increase in the kinetic energy of the molecules, which increases the frequency and effectiveness of collisions between the reactant molecules. The Arrhenius equation describes the relationship between temperature and reaction rate. K equals a EEA/RT, where K is the rate constant, A is the pre-exponential factor. EA is the activation energy, R is the gas constant, and T is the temperature. The Arrhenius equation shows that an increase in temperature leads to an increase in the rate constant, which results in an increase in the reaction rate. Temperature and equilibrium constant. Changes in temperature can also affect the equilibrium constant of a chemical reaction. The equilibrium constant, K, is a measure of the extent of the reaction and is dependent on the temperature of the reaction. The Van 't Hoff equation describes the relationship between temperature and the equilibrium constant. Lane K2/K1 equals delta H/R1/T2 to 1/T1, where K1 and K2 are the equilibrium constants at temperatures T1 and T2, respectively. Delta H is the enthalpy change of the reaction, R is the gas constant, and T1 and T2 are the temperatures. The Van 't Hoff equation shows that an increase in temperature leads to an increase in the equilibrium constant for an exothermic reaction and a decrease in the equilibrium constant for an endothermic reaction. Factors affecting temperature dependence. The temperature dependence of chemical reactions can be influenced by several factors, including the activation energy, the reaction mechanism, and the presence of catalysts. Reactions with higher activation energies are more sensitive to changes in temperature than reactions with lower activation energies. The reaction mechanism can also affect the temperature dependence of a reaction. Reactions with complex mechanisms are typically more sensitive to changes in temperature than reactions with simple mechanisms. Catalysts can also affect the temperature dependence of a reaction by lowering the activation energy, which makes the reaction more sensitive to changes in temperature. Applications of temperature dependence. The temperature dependence of chemical reactions has many important applications. For example, the Haber process, which is used to produce ammonia from nitrogen and hydrogen, relies on the principles of temperature dependence.